Alright, we will try this again. Yeah, technology is great. Alright, so any questions? That's like shockingly bright. Yeah, right. All right. Well, let's continue digging into classes. Um, I want to look a little more at making classes and interacting with objects, and then I want to talk about constructors, and then we're going to get into public and private and all kinds of things like that. And when we're done with this, we should have more than everything we need to do PA1. And tomorrow we'll start off by going through PA1 in great detail. And for the record, you're not screen sharing. Well, yes, you are right. All right, and my screen did not go dark. All right, cool. Thank you. All right, so we're going to make our rectangle class. We're going to have a height and a length, and we'll just leave it at that for now. It's typo Thursday. Let's see, won't add any new files though, which I keep forgetting. Oh, for committing. All right, so this is a little bit where we were yesterday, except we had a two-string function and such. So let's think about our rectangle class. So when we did this yesterday, we wrote code that said, you know, let's make a rectangle and let's set the length to this and let's set the height to that, and so on and so forth. So the first thing to think about is, you know, when we make a linked list, we want a sentinel node. When we make a binary tree, we want a null root. When we make a stack, we want an array of some size and a stack pointer that's initialized to 0. Usually there's some kind of initialization that happens when we create, you know, these data structures. If we make a hash, right, we have to have an array, we have to set valid flags to 0 and deleted flags to 0 and so on and so forth. So the logical place to do that is when you actually say, hey, I want a rectangle, right? So let's do the following. Let's print out the dimensions of R1. I'll print out R1 length and R1 height. And it tells me R1's a 0 by 0 rectangle. Alright, the reason that is because when I say give me a new rectangle, I haven't told it to do anything. I've told it that this rectangle will have two integers, a height and a length, but I haven't said where those come from or what they mean. And in particular, I haven't given them a value. So they get zeros by default. Well, a 0 by 0 rectangle is probably not very interesting to us. Probably in my main program, what I'm going to do after I make a rectangle is say R1 length is 3, R1 height is 5, right? I'm always going to want to do that setting. So what I'm going to do is I'm going to define a constructor, right? A way to create a rectangle that that lets us specify the length and the width. That's a really good existential kind of question. Does a 0 by 0 rectangle count as a square? I think it's a circle, personally. Maybe even an ellipse. But that's a really good question. All right. So let's make a constructor for making a rectangle. So the way we make a constructor, we use the word, well, we use the word public. We don't need the word public, but I'll put it in there anyway. Constructors do not return a particular type of object, right? They're always going to return whatever object we're constructing. So we don't specify the return type in this definition. This is going to look exactly like any other function or method, except we don't specify a return variable type. So we're just going to say public rectangle, and let's give it a pair of arguments. So I'll call this h for height and integer l for length. And my plan is to make a rectangle that's h by l. Well, how do I make a rectangle whose height is h? Just height equals h. And how do I make a rectangle whose length is l? Just length equals l. And then I'm just going to return. Okay, so when I call this constructor, there's stuff that's going to happen automatically. There's going to be something like a malloc inside the Java virtual machine that's going to, set aside space for this object, and there's going to be references made to it and updated and all that kind of stuff. But in addition, I'm saying I want to set the height to h and the length to l. All right. So this hopefully seems legit, but guess what? It's not. I suddenly get an error. And the error is constructor rect and class rect cannot be applied to given types. It tells me I'm at line 4 of my main program. So there's line 4. And I'm trying to say R1, rect R1 equals new rectangle. And it's saying what's required, a pair of integers. What did it find? No arguments. What's the problem? The actual and formal argument lists differ in length. Right? I called my constructor with no arguments, but it's expecting two arguments, an integer and an integer. Alright? So that's about as clear an error message as we could probably hope for. That basically I'm trying to construct this with no arguments, but my constructor needs two arguments, two integers. So what happens is you always have a default constructor that takes no arguments, but once you define a constructor yourself, that default goes away. So I can't construct with no arguments anymore, but I don't actually want to. What I want to do is I want to construct my rectangle to be, say, a 3 by 5. So I'll do that, I'll recompile, I'll execute, and there's my 3 by 5 rectangle. All right. So this is the first leap beyond where we were yesterday, right? We're defining a constructor. It's taking a pair of integers. It's returning a rectangle whose dimensions have been initialized to that. All right. Let's add some more methods in here. I can never spell perimeter, so I just call it perim. So let's make an area method again. So public int area. It does not take arguments. We don't pass a rectangle to the area method. The area method is called as part of a rectangle, and so it's going to use that rectangle's length and height to calculate the area. And the same thing with the perimeter. So let's play with this a little bit. Alright, so we'll print out R1's area equals, and we'll call R1.area, perimeter equals, and we'll call R1.perim. That's true. Alright, so it's 3 by 5, area is 15, perimeter is 16. And then we ended yesterday talking about the two-string method, and we kind of got rushed at the end. So let's re-implement our two-string method, right? We want to print out R1 by concatenating it to a string. In this case, the string R1 equals, and I'm using the plus sign for concatenation. I want to concatenate R1 onto it. And by default, it turns it into the string, which is the class name, the @ sign, and the funny symbol. So we said yesterday we could convert a rectangle to a string. So we do this by making a public method that returns a string, and it's got to be called toString, and it takes no arguments. And I'm just going to return a really crazy string here, right? When you ask me to convert a rectangle to a string, you're going to get back the string a rectangle 3 by 5 parentheses area equals 15 close parenthesis. All right? So that's a pretty wordy way to convert this thing to a string, but that's okay. So when we run that, R1 equals a rectangle 5 by 3 parentheses area equals 15. All right, so that's kind of where we left off yesterday. And this toString method is very particular. It's got to be named toString. It's got to return string. Can't take any arguments. All right. So this is a good place to let's talk about constructors. All right, let's talk about signatures. I got weirdness going on. Hold on. All right. Signatures. Spelled wrong. All right. In C, you make a function called fun. That function is identified by its name and its name alone. Anytime I call fun, I'm going to call this function. And I might set this up to take an integer. But you know, if I call it with a character, that's okay. It will do something with the character that you know, is kind of like an integer. Character is like a very, very short integer. But if I call this thing with an array, right, x is going to be the value of that array. Well, that's the address of the first element in the array. But, you know, the function doesn't know that it got past the address of an array element. It thinks it's got an integer, and it's just going to do whatever it's supposed to do. And if maybe function is supposed to tell whether or not x is prime, and I call this with the string hello, well, you know, whatever address this is stored at, my function's going to see if that address is prime. It's a really weird thing to do, right? And we might get some warnings from the compiler if we do this. We might not. But you know, there's only one function. So in Java, things get a little more fine-grained. So we have this notion of the signature of a function. And in C, the function is basically, the name of the function is its signature. It's the way you identify a function. In Java, the way you identify a function is by two things: the name of the function and the types of arguments. So the type of each argument, which includes, you know, the number of arguments. And the combination of those uniquely identifies a function or a method. So this means that in Java we could have 2 or 3 or 4 different methods all named fun. But they would be different because they would take different types of arguments. Let's see what's going on in chat. In the same way with GCC options, we can see the underlying assembly code. Is there a tool option to see the underlying C or C++ code that's generated? Does JVM kind of mess that possibility up? Okay, so yeah, so good conversation going on in chat here. So yeah, Java does not get compiled into C, and it does not go through C. It goes into something called bytecode, and it's just another binary language which is not understood by an x86 processor or an ARM processor, but by the Java virtual machine, this synthetic processor that runs when we say Java. And I think it's a stack-based machine, at least originally. But, you know, it's got an architecture and an instruction set and so on and so forth. And you can look at the bytecode by looking inside the class file. And, yeah, there's almost certainly simulators out there for the JVM and ways to step through it and so on and so forth. So, yeah, exactly. It's a form of assembly, but for JVM bytecode instead of x86. Is there a reason to compile a high-level language into C? Yeah, definitely. Actually, the advantage of doing that would be, I mean, it's an easy way to write a compiler, right? So you come up with your own language and convert it into C, and then you can feed that to, you know, your system C compiler to actually do all the optimizations and conversions, memory management, link in with runtime library and all that kind of stuff. But yeah, you'd need to have a kind of pretty special language to make it interesting to someone to compile it into another high-level language. But that can definitely be done. Alright, so signature is not just the name, but it's also the type of argument. So this comes into play definitely in terms of constructors. But let's do this. Let's just add an integer argument to my toString method. Okay, this will still compile, and it will still run, But when I print out the value of R1, I'm back to my old default rect @ address, right? Why did that happen just by adding an argument to this? Because this is no longer the magic toString function, right? This method has a different signature from the method of toString that's going to be used to concatenate a rectangle to a string. This is not getting used at all, right? When I say, let's print out, R1 equals and then concatenate R1, so we have to turn this into a string, it's calling the default toString method. It's not even touching this because this is not the same method. It has a different signature. So that's one way to see where this comes into, but the more kind of pertinent application is with constructors. So suppose we wanted a default constructor. Suppose we wanted to be able to say something like let's just make an empty constructor and then let's see what it looks like. Alright, we got the problem we don't have a default constructor. I also didn't give this a type. Alright, so let's fix this. Let's make a default constructor. And what should we do if the person tries to make a rectangle without giving us dimensions? I don't know, what dimensions should we make it? Whoever pipes up first, you get to name this for eternity. Pineapple. Oh, okay. Since we can't do pineapple, so we'll make it like that. So we'll make public rect, and we'll say this does not take any arguments. And we'll set the height equal to this, and we'll set the length equal to this. Alright. This isn't going to work because these are going to be too big for the compiler, I think. But yeah, so that would be our default rectangle if we don't specify. Those constants are too big. So, but I like those constants, so I'm just going to take off a few places there. Up one more. There we go. Alright, so so R2 was a rectangle that by that, and the area was, look at that, our area went negative. Yep, the area overflowed, so bigger than 2 billion, and it wrapped over and became a negative number. That's true, I could have done pine and apple. Alright, so let me make these just a little smaller so we don't get... Nope. Alright, I'll just live with negative areas. I'm okay. Alright, so that's a default constructor, right? So now we can construct with 2 arguments, we can construct with no arguments. We could make a square constructor. If we want to make a square, we can construct a rectangle with just 1 argument, which is the length of a side. So we'll make a 17 by 17 square. Right, so R3 is 17 by 17. All right, so this is useful, right? When you made your linked list classes or structures, you know, in 222, and you wanted to create a node, maybe you make a separate function for creating a node, and you might have had a decision to make, like, should I initialize the data value to 0, or should I let the person pass in a value and have that become the data value? And you know, maybe sometimes you want to do one, sometimes you want to do the other. If you're making a Sentinel node, you don't really care what the data value is. Maybe you just wanted to give it a default value. But maybe when you're doing an insert, you want to make a node and then set the data value. Well, you could make 2 constructors for your node class, and then you could have your choice. Got some deep wisdom going on in chat. Cool. All right. So signatures, right? Now the type of return value from a method is not part of the signature. And if I try to make 2 methods that return different things, then I'll get an error from the compiler saying this conflicts with something else. But different types of arguments or different numbers of arguments we can do. I could make a new constructor that takes, you know, a character C. So there's a constructor that takes an argument. If the argument is B for big, it'll make a 100 by 100 rectangle. Otherwise, it'll make a 1 by 1 rectangle. All right, got the idea? All right, so let's talk about this private versus public business, and let me clean up some of this stuff, and let's just stick with our 3 by 5. All right, so I'm going to post this on the server, so I'm keeping my code in there. So we can make a 3 by 5 rectangle, and we can print it out, and it'll tell us it's a 3 by 5, and it has an area of 15. All right, well, here's something weird that can happen, right? This has already happened to us, right? But I could specify a rectangle with a negative length or a negative height. And you know, if I give it a height of 2 and a length of -2, its area will be -4, its perimeter will be 0, which is a little weird. And this might cause problems. Now, we just saw we could cause problems by putting in really big dimensions and overflowing. But you know, ignoring that, this could cause problems, right? Maybe I have something that takes the square root of the area, and if my area is negative, I might crash my code. And if this is, you know, running on a web server on my Swiss bank account, you know, so it might be really bad to let the person build a rectangle with negative dimensions. So what we can do is we can go inside our constructor, and we can do the following. We can check to see if these things are negative, and if they are, we can flip them. So now, you know, my area is well behaved, my rectangle is well behaved. Does Java have a notion of unsigned types? I was about to say yeah, definitely, and I'm actually not sure. I never use unsigns in C, so I don't use them in Java, but I don't actually know if they exist or not. I'm going to guess that they must, but I don't know for sure. Alright, so here's a way to stop the person from constructing a rectangle with negative dimensions. Right? The problem with this is this doesn't stop the user from doing this. Right, so we're back to a negative dimension because they said r1.length equals -5. So how do we stop the person from doing this? Make these things private. And now when you try to compile, you're going to get a compile error saying, hey, length has private access in the rectangle class. You're not allowed to set the length value. Alright, so we can use private to support information hiding and encapsulation, right? If we have a variable we don't want outside access to, we can just mark it as private. For example, the stack pointer in our stack implementation. We don't want something outside directly manipulating the stack pointer. It gets manipulated when you say push or pop or init, but we don't really want some code outside saying, you know, SP++, or looking to see if SP is 0. So we can mark it private, and there's no access allowed from outside. Yeah, like directly manipulating the IP address inside a network system. Alright, so there's one obvious downside to this, which is what if you've constructed a rectangle that's, you know, 3 by 5, and now you want to change a dimension, you want it to be a 3 by 7 rectangle. Right? We can't do that because, you know, because we don't have access to that length. If we allow access to this length, then there's the possibility that somebody will give it a value that's going to corrupt something. So what do? So this is where we create accessors and mutators. Alright, so what's the idea here? We're trying to block direct access to this field by making it private, but we still want to allow, under some conditions, outside class to look at and modify the length and the height of the rectangle after it's been constructed. So we do that by making a pair of functions. So we have something called an accessor. This is just a public method that returns an int. And it just looks like that. Now if my main program tried to access, you know, r1.length, it would get this compile error. But it can definitely access r1.getLength paren because that's a public function. It's a method. And the getLength method has access to length because it's in the same class. So yeah, these are also called setters and getters. No unsigned int as a primitive type. Okay, but yeah, there's class implementations of it, for sure. Alright, so we can make a pair of accessors. Cool. Yeah, I need to know more. Actually, I don't know any C sharp. I was thinking C++. So C sharp is a different approach to object-oriented design. You know, arguably similar to Java in some ways. But yeah, that's another language. So C++, C sharp, Java, three object-oriented options. All right, so these are accessors. These will let us read values of variables. We can also make mutators or setters. So these don't need to return anything, but they'll take an argument. And so in our main program, instead of saying r1.length equals 7, we can say r1.setLength 7. See how I did on typos, not bad. And so we can change it to a 7x3 rectangle. Now, the nice thing about this is, you know, if we just leave it like this, we've got the same problem we started with, which is the person could set the dimensions to be something bizarre. But in our mutators, we can do something like, you know, let's say if they try to put in something that's less than or equal to 0, we'll set it equal to 1. And so now if they try to make, you know, a -7 length, it just ends up being 1. So accessors and mutators allow us to give controlled access to areas of our class that we want control over. Now, if we have something that's purely internal to our class that we don't want any outside access to, we just make it private. But if we have a field that's private, but we still want to allow some access, we can make a setter or a getter. And the very, very standardized way to do this is to make a method called get, followed by the name of the variable that you're trying to get. And I typoed here. But it should be camel-cased. So if my variable is called height, it should be uppercase height. And get length, uppercase length. And the same for the mutators. And this is totally standard. And when we start playing with IDEs, right, if we do something in Eclipse, for example, when you create a class and you've got some fields in there, right, you can use a few mouse clicks to automatically get these things written for you, right? Say automatically create setters and getters for these fields. So that's a mechanism we'll encounter a lot, right? It's basically, again, a way to control access to fields, but still allow access as we choose. All right, questions up to here. There's a lot of stuff we're going through. There's a lot of mechanics and there's a lot of concepts. Alright, silence is either really good or really not good. Okay. I will assume it's all good then. The setters and getters were in the rectangle class, correct? Right, so this is rectangle.java. And it's a way to expose through the getters and allow modification of through the setters these fields that are marked private. Okay, cool. No longer confused is excellent. If you look online at any of this stuff, you're going to see the word this pop up. You're going to see this dot height and this dot length. Ignore that for now. We'll talk about the this keyword later on, but for now, you know, I'm just going to call this argument h and just set height equal to h. And this thing is optional at this point, so you can ignore it. Out of curiosity, why do we learn Java in this course instead of C++? Partially WSUV, which does a lot of Java. I think that's probably the main reason. I also think Java, I don't know, personal bias, I find Java a lot more logical than C++. Maybe that's the order I try to learn them in. But you know, also Java is super portable, and it leads you into things like Android, if you're not doing Kotlin and stuff. Yeah, Arduino is mostly C++. It's a little bit different, but it's very C++ like. We do spend a lot of time in C, and that's mainly because C is sort of like building blocks, right? C is assembly language. Right, it's a high-level version of assembly, but it's really, you know, a way to do assembly language manipulation of hardware without having to do everything that goes into, you know, x equals negative b plus or minus the square root of, being able to do that in a high-level way. But it's low-level in the sense that assembly language is low-level, and that makes it really well suited for doing things like let's implement a linked list by actually creating some nodes in memory and twiddling their pointers to point to one another. Whereas in, yeah, so it's like the grandparent of many languages. So in Java, right, we sort of have all that stuff available for us. We can just say, you know, I want a set, or, you know, some kind of collection, and all that machinery is done for us. And so C is sort of the building blocks, even though we build into Java. Well, I mean, Java's written in C++. So yeah, that's the main reason. And I've had students who have told me that, you know, they hated C when they were learning it. They used to go home and they'd throw their book across the room, and they'd curse my name, and they've told me, you know, in retrospect, that they're so glad they learned C first, because if they had learned Java, they never would have learned C. Because, you know, yeah, the ampersand and the star and all of that stuff is so low level, and, you know, going into GEB and figuring out what's pointing to what and what's at that location, and is this big endian or little endian, and which byte goes where, that stuff is so painful, right, and so unpleasant, but really important to do. And a rough analog is, you know, learning calculus. When you do a derivative as, you know, f of x plus delta x minus f of x over delta x, and you do the limit, right? You're never going to do that once you know how to take derivatives. You're never going to go back to an epsilon delta proof once you know limits and rules for limits and L'Hopital's rule and all that, right? But if you never do those things, then those other concepts like, you know, calculating limits or finding derivatives using formulae, they don't really lend themselves to use as well. That is interesting. Yeah, I knew Minecraft was written in Java originally. I didn't know it had been changed to C++, but I'm guessing, yeah, Microsoft. Cool. All right. My plan tomorrow is basically spend at least the beginning of tomorrow going through PA1, and we'll go through the assignment. We'll talk about what all of it means. We'll look at some applications. You're going to be developing a class of your own for implementing rational numbers, fractions, and we'll look at some ways to use that. I'll show you some main program code and some test code you can use, but we'll play around with the class and see what we want it to do. And then your goal for PA1 is going to be to basically come up with your own implementation of that class. And it's an assignment. You've got pretty much everything you need to do already, but it'll be a good kind of like, guiding task to help you get more practice using these concepts and ideas. We will also go over Euclid's algorithm tomorrow. So my winter 215 class, we did not get to Euclid's algorithm for finding greatest common factor, and we're going to need to do that for PA1. So we'll do a quick review of that. That's our plan. We're out of time today, so have a good afternoon. I will see you tomorrow. Thank you.